This content is brought to you by Mazunder Academy.
Hello everyone. Today in this session we will study about different operators in R. So the first one is assignment operator. We will see how and which way we can assign data to a variable, arithmetic operators, relational operators, logical operators, special operators, and then operator precedences. So without further delay, let us start first with our assignment operator. So as I have mentioned, you can see in the screen, you can see on the screen equal sign, then less than, hyphen, hyphen greater than, hyphen double greater than, double less than, then hyphen. So these are the different operators used to assign any data to a variable. For example, x equal to 5. Then say for example I want to assign 3 to y, so I can write like this. Then if I want to store, say for example 7 to another variable, say z, then for example I want to store in a 11, or say for example I want to store 15 in another variable b. So this all way we can assign, and if you want to check whether it is assigned properly or not, you can select and run, and then if you want to display, so just give the variable name, say for example y, and control enter. So you can see 3 is assigned in y here. So this is all about your assignment. Next we will see arithmetic operators in R. So to carry out mathematical operations we need arithmetic operators. As we all know, plus is for addition, minus for subtraction, star for multiplication, and this division, this is normal division with point. Then this symbol is for exponent. Then double percent symbol used for modulus. Percent divide percent is used for integer division. So this one will result only the integer after the division. Remainder will not consider in this case. I will show you during demonstration all this. So let's start. Already I have these values x5, y3. So I will use this. For example, if I do x plus y, and if you run, you will get 5 plus 3 is 8. Similarly, if you do x minus y and run, you will get 2. X multiply y, you will get 15. And x divide y, you will get 1.6667. If I want to use modulus to see the remainder, then x modulus y. So in this case 5 will be divided by 3 and you will get the remainder 2. Then if we want to do the integer division, then x percent divide percent y. If you run, you will get 1 as quotient. So this will give you quotient, this will give you remainder. So that's all about the arithmetic operators. Let's switch to relational operators. What are the relational operators we have? Less than, greater than, less than or equal, greater than or equal, then not equal. We will see all this, and always remember relational operator will result as output as either true or false. Only logical output we will get either true or false. Okay, so let's see. For example, I have x equal to 5 and y equal to 3. So if I do say x greater than y, so 5 greater than 3, it should be true. So we can see here output, it has come true. Similarly, if I put say x less than y, I will get false, because 5 is not less than 3. Similarly, if I put x equal y, so I will get false. If I put x not equal y, I will get true. And similar to the others, if I put x less than or equal to y, I will get false. Similarly, if I put x greater than equal y, I will get true. So these are the different relational operators we have. Then we will switch to logical operators. Here also output will be either true or false. And the logical value of 0 is considered as false, and any other non-zero value will be considered as true. There are mainly three logical operators: logical not, and or. So if you use only one ampersand sign, then it will be element wise logical AND, and if you use two ampersand sign, it will be normal logical AND. Similarly for OR, if you use only one symbol, this one, then it will be element wise logical OR, and if you use two, then it will be logical OR for the complete whole variable will be considered as one. So let's see a few example of it. For example, I have stored 0 in A, so its logical value is false, and I have stored 2 in B, its logical value is true. And say V1 and V2, we have two variables, basically they are vectors. We will come to know about this very soon in our subsequent lectures, probably in next couple of lectures it will reach to vector. Basically V1 and V2, these two are vectors, and we use function C to create vector. Now V1 is a vector created. What are the data inside 0, 5 and 6? So the logical value of these values will be first one false, second one true, and next one will be true. Similarly, I have created another vector 1, 2, 3, and the logical value all will be true. Now if I run V1 and V2 with only one symbol, one ampersand sign, in that case what it will do, it will compare the element wise comparison. You can see here false, true, true, and behind that, what is the logic? We all know it from our previous knowledge. Here you can see how AND operator works. True and true will be true, true false it will be false, false true will be false, false false will be false. Similarly for OR operator, you can see true true true, true false true, false true true, false false false. And NOT operator, we know it will just inverse the input. True will become false, false will become true. So we can see false, true will be false, then true 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 true. So these are the logical output. But if I do double ampersand, in that case it will give me only one result, that is false, because you have only, if you have one false, that means all will be false only, AND operator. And this is just a warning, because it is saying that a length of x is equal to 3, which is greater than 1. Okay, it's a warning, not an error. Generally this operator should have only one value, but here we have supplied 3 values, that's why. So it's not a matter, but mainly we will use this one only, because these operators are used in conditional statement to check some conditions. For example, there is an example given. If this if statement and all, it is a requirement for this moment I have used, but in details we will study it later. If x, the value of x is bigger than 0 and y bigger than 1, then print high. So what was the value of x for us? It was 5, and value of y 3. So both true. So this condition is true. So this part is true, this part is true. So true and true, it will be true, it will give us true, and if the condition true, this part will be executed. Therefore it will print high. You can check here, it will print. Similarly, OR operator you can do, v1 or v2, you will get individual output, and if you do two OR symbols, then you will get only one output, and that will be true. So this all about our logical operators, what we have seen here. Next we have very important special operators. In R we have three special operators, and one more also. It is sometimes not considered as operator, but I am including it here. So first one is colon, next percent in percent, then percent star percent, and percent greater than percent. Let us see what are these operators. So this colon operator used to create a series of number from left operand to right operand. Your A is the left operand and B is the right operand from A to B, and it will give the gap of 1. It will start from the value A up to value B with a gap of 1. I will show you in demonstration. For example, write a R program to store the data 1, 2, 3, 4, 5, 6 up to 50. So one way is using the vector. Individually 1, 2, 3, 4 up to 50 all data you will supply, or other way is you can write V equal to C1 colon 50. So it will create a vector from 1 to 50 with a gap of 1. And if you want to see the output of this, so print V. You just run these two statements, you will see your output 1, 2, 3 up to 50, all stored in variable B. So this is one use of colon operator. Next we will see in operator. We use in operator if we want to check whether a particular element is present in another vector, or a vector whether it is present in another vector. In both the cases we can use in operator. So just for an example, say already we have created V. If we just run V, then we can see the value of V are 1, 2, 3 up to 50. Now suppose we want to check some number, say 10, whether 10 is present inside V. This specially requires when if you have a large data set where you want to check some elements, whether these elements or a particular element is available inside the vector or not. For example, if I want to check 10, whether 10 is available in V, then we can write 10, then percent in percent, and then the vector V. So in that case, if you run, then you will see your answer will be true because 10 is present here. If you have a number, say for example, it is 100, and if you run it, then it will come false. That means it is not there in that vector V. 100 is not there. Now instead of one number, it can be sometimes another vector. For example, I want to check whether 0, 6 and 7, these three numbers are available in the vector V or not. So if we run this code, it will give me So if I run this code, it will give me false, true, true. Why? Because 0 is not there in V. You can check here, 0 is not there, 6 is there, 7 is there. So for the case of 0, we will understand it is not there, that's why it is showing me false. Then 6, it is there, so it is true. 7 also there, so it is true. So this is the way we can use in operator to check some elements or a vector, whether it is available inside a data set or inside another vector. Next, we will move to %*%, this operator. Basically, this is matrix multiplication operator. If we want to perform matrix multiplication, we use this operator. So here again, I'm going to use a function which is not explained still now, but it is a requirement for the time being to explain that operator. Later on, we will study this function in details and we will see how different operations can be done. I have used matrix function to create two matrices M1 and M2. So let's first run M1 and then M2. So two matrices created. If we want to see, then we just write M1 and run it. So you can see the matrix 1, 2, 3, 4, 5, 6. Similarly, if you want to see M2, just run it. You will see M2 also. Now matrix multiplication, M1 multiply M2. So M1 %*% M2. So this will result me the matrix multiplication. If I run it, I can see this is the result of matrix multiplication. Next, V1 is a vector, V2 is another vector. 1, 2, 3, 4, 5, 6, as you can see in the screen. And if we multiply V1 multiply V2, then what will happen? It will give me a single element. Next, say for example, you have V1 and V2 two vectors and their dimensions are not same. They are of different dimensions. So as a matrix, if we consider, then it will be V1 is 1 by 2, V2 is 1 by 3. Now if we multiply, then what will happen? You can see you will get an error, non-conformability error. That means the number of elements and the number of rows and columns, that conformability conditions is not satisfied here. So you cannot multiply. Similarly, sometime it will be conformable for multiplication, sometime not. Let's go further with the next operator, that is called pipe operator, and this is very important operator. Using this operator, we can reduce the number of lines or the code. We can combine many codes together in one line, and standard programmer use this pipe operator to reduce their number of lines or number of steps in the program. So let me tell you something about the pipe operator. What is it? The pipe, this symbol comes from Magritte package. So that means you have to install this package Magritte before using this pipe operator. And then of course, after every package installation, you have to load them into library. You can use pipe operator to pipe together a sequence of operations. The basic syntax of pipe operator is, say for example, a data frame. It will be piped to do this operation. Whatever the result will come, this result will be piped to another operation. This result, whatever comes, that will be piped to the next operations, and so on. And the most important point here is, when you use this pipe operator, how the arguments will pass. It passes the left hand side of the operator to the first argument of the right hand side operator. For example, if you have this x pipe operator fy, that means it is nothing but a function of f x comma y. So this is a very important point for you. Whenever we will use pipe operator, this way the function will be constructed. This x will be the first component or the argument of the function f. Let us apply this. So first of all, you have to install package MAGRITTR install. It will take little time to install. It is done. Once installation done, now you have to load into the library. So library migrator and run it. So it is loaded. Now V3 is a vector I have created from 1 to 20 data. Then what work we are going to do here using this pipe operator? I want, say for example, if I want to see the data of V3, so V3 you see 1 to 20, and I want to filter this V3, this data I want to filter in which way? V3 less than or equal to 10. That means 1, 2, 3 up to 10. This data should be piped in sum function. That means I want to find out the sum of this data. And during this sum function, it will ignore the remaining. From V3, it will extract all the data value which is less than or equal to 10. And it will be piped in sum function. And finally, the sum function, it is a standard function. This will give me the result of the sum of all these data. So let's see how does it works. You can see if we find out the sum of all the data from 1 to 10, you will get 55. The last concept is operator precedence. So R follows the order of operations where the precedence follows the BEDMAS order. Bracket, exponent, division, multiplication, addition, and subtraction. Almost same as we did in mathematics. For example, this is an expression. So k is a variable where x plus y multiply y minus 1 bracket power 3 minus y. So as per this brackets will be the first. So it will first work y minus 1. Then exponent, then it will make the power of this, and then division not there, multiplication will be done next. So next multiplication, whatever the value will come from here, this value will be multiplied with y, and then finally addition, this value will be added with x, and then finally this all answer from here y will be subtracted. So to check this value, if we do some say for example x equal to 3 and y equal to 4, and now if we run this data, we can see the value will come out 107, and you can check it by calculator. This is the way R follows the operator precedence.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.